Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about fluid mechanics. Impact of jet. When a jet of water strikes a surface, its velocity, and hence its momentum, is changed. The force exerted by the surface on the jet is then obtained by applying Newton's second law, i.e. the force normal to the surface is equal to the rate of change of momentum, or change of momentum per second, normal to the surface. The force exerted by the jet on the surface is equal and opposite to this force. A jet of water issuing from a nozzle has a velocity and hence it possesses a kinetic energy. If this jet strikes a plate, then it is said to have an impact on the plate. The jet will exert a force on the plate which it strikes. This force is called a dynamic force exerted by the jet. This force is due to the change in the momentum of the jet as a consequence of the impact. This force is equal to the rate of change of momentum, i.e., the force is equal to mass striking the plate per second times change in velocity. The liquid comes out in the form of a jet from the outlet of a nozzle, which is fitted to a pipe through which the liquid is flowing under pressure. If some plate, which may be fixed or moving, is placed in the path of the jet, a force is exerted by the jet on the plate. This force is obtained from Newton's second law of motion or from impulse-moment equation. Thus, impact of jet means the force exerted by the jet on a plate which may be stationary or moving. The following cases of the impact jet, i.e., the force exerted by the jet on a plate, will be considered. Force exerted by a jet on a stationary plate when plate is vertical to the jet, plate is inclined to the jet, and plate is curved. Force is exerted by the jet on the moving plate when plate is vertical to the jet, plate is inclined to the jet, and plate is curved. Force exerted by a jet on a stationary vertical plate. Consider a jet of water coming out of the nozzle, strikes a flat vertical plate as shown in the figure. As we can see, we are having a pipe. At the end of the pipe, we have nozzle. The water flow through the nozzle, with the velocity v. When it strikes the stationary or fixed plate, with velocity v, after striking the plate water moves tangentially and its velocity after striking is neglected. Let ρ equals density of water, A equals area of cross-section of the jet equals PD2/4, V equals velocity of the water jet. The jet after striking the plate will move along the plate. But the plate is right angles to the jet. Hence the jet after striking will get deflected by 90 degrees. Hence the component of the velocity of the jet, in the direction of the jet, after striking will be 0. The force exerted by the jet on the plate in the direction of the jet, F N equals mass striking the plate per second times change in velocity in the direction of impressed forces, equals m times v minus 0 F N equals m times v. Equation 1. Now, m equals mass flow rate and is equal to volumetric flow rate times density. The unit of volumetric flow rate is cubic meter per second. And unit of density is kilogram per cubic meter. Now, m equals volumetric flow rate times density, m equals discharge times density, m equals q times rho, where q equals a times v, m equals a times v times rho. Equation 2. Substituting the value of m from equation 2 in equation 1, F N equals m times v. Equation 1, m equals a times v times rho. Equation 2. F N equals a times v times rho times v F N equals a times rho times v2. Equation 3. This is one of the expression for normal forces. For deriving the above equation, we have taken initial velocity minus final velocity and not final velocity minus initial velocity. If the force exerted on the jet is to be calculated, then final minus the initial velocity is taken. But if the force exerted by the jet on the plate is to calculated, then initial velocity minus the final velocity is taken. Force exerted by a jet on a stationary inclined flat plate. Let a jet of water, coming out from the nozzle, strike an inclined flat plate as shown in the figure. Let ρ equals density of water, A equals area of cross-section of the jet equals PD2/4, V equals velocity of the jet in the direction of x. Theta equals angle between the jet and the plate. Then the mass of the water per second striking the plate equals ρ times A times V. If the plate is assumed smooth and if it is assumed that there is no loss of energy due to the impact of the jet, then the jet will move over the plate after striking with a velocity equal to initial velocity, i.e. with a velocity v. Let find the force exerted by the jet on the plate in the direction normal to the plate. Let this force is represented by F N. Then F N equals mass of the jet striking per second times initial velocity of the jet before striking in the direction of N final velocity of the jet after striking in the direction of NF. N equals rho times A times V sin theta minus 0 F. N equals rho times A times V2 sin theta. If the force can be resolved into two components, one in the direction of the jet and the other perpendicular to the direction of the flow, then we have F x equals rho times A times V2 sin 2 theta along the direction of the flow, and F y equals rho times A times V2 sin theta times cos theta perpendicular to flow. Force exerted by a jet on a stationary cover plate. Jet strikes the curved plate at the center. Let a jet of water strike a fixed curved plate at the center as shown in figure. The jet after striking the plate comes out with the same velocity if the plate is smooth and there is no loss of energy due to impact of the jet, in the tangential direction of the curved plate. The velocity at the outlet of the plate can be resolved into two components, one in the direction of the jet and the other perpendicular to the direction of the jet. Component of velocity in the direction of the jet equals minus v cos. Negative sign is taken as the velocity at the outlet is in the opposite direction of the jet of water coming out from nozzle. Component of the velocity perpendicular to the jet equals v sin theta. Force exerted by the jet in the direction of the jet, F x equals mass per second times v. 1x minus v 2x, where v 1x equals initial velocity in the direction of the jet, which is equal to v 2x equals final velocity in the direction of the jet equals v cos theta f. X equals rho times A times VV minus dash minus V cos theta F. X equals rho times A times VV plus V cos theta F. X equals rho times A times V2 1 plus cos theta. Similarly, F y equals mass per second times v 1y minus v 2y, where v 1y equals initial velocity in the direction of y, which is equal to v v 2y equals final velocity in the direction of the jet equals v sin theta f y equals rho times a times v0 minus v sin theta f y equals rho times a times v minus v sin theta f y equals minus rho times a times v2 sin theta. Negative sign means the force is acting in the downward direction. In this case, the angle of deflection of the jet equals 180 degrees minus theta. Jet strikes the curved plate at one end tangentially. When the plate is symmetrical, let the jet strike the curved plate at one end tangentially as shown in the figure. Let the curved is symmetrical about x-axis. Then the angle made by the tangents at the two ends of the plate will be same. Let v equals velocity of the jet of water. Theta equals angle made by jet with x-axis at inlet tip of the curved plate. If the plate is smooth and loss of energy due to impact is zero, then the velocity of the water at the outlet tip of the curved plate will be equal to v. The force exerted by the jet of water in the direction of Zandjaer, F x equals mass per second times v 1x minus v 2x F x equals rho times a times v cos theta minus dash minus v cos theta f x equals rho times a times v cos theta plus v cos theta f y equals rho times a times v 1y minus v 2y f y equals rho times a times v sin theta minus v sin theta, which is equal to 0. Jet strikes the curved plate at one end tangentially when the plate is unsymmetrical. When the curved plate is unsymmetrical about x-axis, then the angles made by the tangents drawn at the inlet and outlet tips of the plate with x-axis will be different. Theta equals angle made by the tangent at the tip with the x-axis. F phi equals angle made by the tangent at the outlet tip with x-axis. The two component of the velocity at inlet are v 1x equals v cos theta and v 1y equals v sin theta. The two component of the velocity at outlet are v 2x equals minus v cos f phi and v. 2y equals v sin f phi. The force exerted by the jet of water in the direction of Zandjaer, F. X equals mass per second times v. 1x minus v. 2x F. X equals rho times a times v cos theta minus dash minus v cos f phi f. X equals rho times a times v cos theta plus v cos f phi f. Y equals mass per second times v. 1y minus v. 2y f. Y equals rho times a times v sin theta plus v sin f phi f. Y equals rho times a times v2 sin theta plus v sin f phi. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.